Autodesk. I'll be your master of ceremonies today. In this presentation around AUD, Autodesk Utility Design with the RUS staking design tool comes to you from sunny California. And the purpose of this presentation is to share with you what the AUD RUS solution is all about. The process of today's presentation is predominantly, I promise you it's not going to be death by PowerPoint, but it's predominantly going to be that of live presentation from a colleague who I'll introduce momentarily, who's online. And the payoff for you at the end of the day, you'll have a better sense of an incredible solution that's available from Autodesk now that enables you to put together your staking sheets very efficiently and very quickly indeed. And this solution is based upon AUD, or Autodesk Utility Design. And extremely briefly, I'm not going to read every single line, I wouldn't insult you on that, but AUD, or Autodesk Utility Design, is built upon AutoCAD Map 3D, and it enables users to plan and design distribution networks from start to finish in a single, very simple environment. The benefits, as you'll see, will abound during the course of the presentation. But let's just carry on. And I wish to just highlight, well, you may be thinking, well, Autodesk and Autodesk with utility solutions. Let's explain some of the players that come to you today or come with the AUD RUS-based solution. There's, of course, me, but we'll move along. I have, by the way, just the best part of 30 years in the CAD GIS industry. Close colleague of mine, Kevin Miller, well over 23, 24 years in the electric utility industry, spent 22 years of that with First Energy Corporation in positions like field office design and estimating, transmission, distribution of planning and standards. Pat Byrne, another close colleague of mine, specifically deals with customers' solutions around water, wastewater, gas and electric utilities. Doug Laszlo, all of these people are great friends of mine too. Best part of 12, 13 years with Autodesk. Prior to that, though, he was with First Energy Corporation as well, working in design, engineering, and operations. My manager, again, another good friend, Joe Travis, worked with Southeastern Reaper Graphics for a long time in Atlanta. Did a lot of work around GPS and mapping-based activities for utility organizations. Again, the best part of 20 years experience in the CAD GIS mapping industry. Alan Saunders, the thought leadership for utilities from Autodesk. Over 25 years in the operations, planning, customer services roles with utilities like PG&E, Pacific Gas and Electric. And of course, my close colleague, and who'll be doing most of the lion work of the presentation today, Mr. Walt Smith. And Walt has the best part of over 40 years in the gas and electric utility industry. You wouldn't think it charming-looking young man there, but doing things like initially as the gas and electric system designer for San Diego Gas and Electric. And I'm sure through the bio and the presentation that Alison gave earlier, I'm sure we explained my role and Walt's role in a little bit more depth. But I wanted to show you some of the motley crew within Autodesk that makes up our knowledge base. We're not just coming to you with this solution from a, oh, wouldn't this be nice? There's some thought process that's gone through this. And Walt, I think it was something like 150 plus years of experience, very roughly on that rogues gallery of photographs. The agenda is very straightforward. 4 main sections. We're going to be showing you this AutoCAD for the staking sheet. Like I said earlier, the process of this is predominantly through live demonstration. And the payoff for you, you'll have a better understanding of what this immediately available RUS staking sheet offering is all about. And we'll be taking questions, I believe, towards the end of the presentation. But honing down, we have, and I have great pleasure in mentioning that I have a colleague on the other end of the line in sunny San Diego, Walt Smith, who will be going through the live portion of the demonstrations. And the first part of this demonstration is Walt dealing with the AUD RUS solution, the staking sheet layout. So Walt, good morning, welcome. I'm going to pass it over to you.
Thanks, Pete, and good morning and good afternoon to everybody that's online. So I'm going to dive down a little bit further into what we consider three pieces of the pie. As Pete alluded to them earlier, it's the layout of that staking sheet, the engineering going into and involved with the RUS standards, and then the material ordering. But first, let's focus on the layout. The staking sheet layout, that's what it's all about. In order to get a nice sketch to the crews, we have to start with that layout. Now, typically with an Autodesk utility design, there's a lot of customization, configuration, and incorporation of the business rules and design standards for a specific utility. Now, the beauty of this offering that we have currently for RUS is that the drawing plots, annotations, the palettes, the menus, the drafting standards are all around the RUS standards. Very specifically allows us to, out of the box with the current offering available today, to have you up and running in a week's time laying out a staking sheet to the generic RUS standards. But what we can do here right now, Pete, why don't we just go ahead and jump right over to the RUS, and let's show the group here exactly what we're talking about in the form of a demonstration. So if you want to go ahead.
Waltz, forgive me if I'm running through this too quickly. Just stop me, will you?
No, that's fine, Pete. This is, and everybody online will kind of know that this is kind of a conversation. The idea here is we wanted to get into the demonstration very quickly and talk a little bit about this. So what I'm working with here right now is the actual demonstration of AUDs configured for the RUS standards. I'm going to focus on the layout first. I'm going to work it as if I'm a staker, and I'm going to talk about specifically the way AUD has been configured. First of all, we take full advantage of the true vertical nature of AUD built on top of AutoCAD map. So therefore, we have all the horsepower of AutoCAD underneath. We have menus, palettes set up on the right-hand side of the screen that moves the user through these processes. For instance, you can see the base map, overhead layout, engineering, material, to name a few. So, but first, a staker needs to go ahead and begin a project. And with that, and a part of AUD is what we call Project Explorer. The Project Explorer enables the staker to keep track of all the individual staking sheets that he or she are working with in the day-to-day goings-on of your utility. For instance, on the left-hand side, it's a Windows Explorer look and feel. I may have staking sheet numbers or individual job titles or developer names or whatnot, enabling myself to keep track of all my projects. On the right-hand side is the appropriate information that goes with the individual staking sheet. For instance, the staking sheet ID, the number, project name, phone number, addresses, and so forth. I may also have information as to township ranges, approval process. A lot of this information all set up, ready to go, and then can be further expanded upon to meet the individual needs of your individual co-op. But what I have here is information, and where does it go? It actually goes onto the individual staking sheet automatically, so that if I have a change here and I update it, it will automatically populate that, as well as any reports for material lists or cost estimates that I generate from the AUD RUS configuration. But enough talk. I'm going to go ahead and jump into an individual job here for a little overhead service and show you how I would work with as far as the staker is concerned. The staker may end up starting with just something as simple as a blank screen, and as in so many cases, the layout is done off of field notes or out in the field, maybe from survey data or GPS data, or just very simply a blank piece of paper like I'm doing here. I'd start with my menu and my palette in the form of a layout. I'm going to insert a poll. It's just a poll. AUD RUS knows it's a poll. It has specific properties, but it's not just a circle. It's an intelligent RUS object. Then from there, I may want to go ahead and draw lines. The individual conductor sizes for single phase to neutral and phase to phase, as well as three-phase, are already pre-populated with the most common wire sizes. For instance, maybe I want to string a piece of 1/0 ACSR, and I want to start off one pole, and I want to go off in a specific direction, and maybe I want to go off 240 feet. I can just simply type it in. I have AutoCAD commands available for me, and then I can go ahead and insert a pole. I drop in a pole, and then I continue on with my 1/0 ACSR and maybe another direction so that I can show you some of the engineering. In this direction, maybe I want to go, say, 190 feet, and then place a pole. So the layout becomes very easy. Now, one of the things that we talk about with the layout is the focus around the staker. By that I mean there's a lot that's going on here. I didn't just draw a line. I drew an actual piece of conductor. So if I click on that piece of a conductor, I can see that the actual length is 217 feet. It's new. It's brand new. It's going from a pole to a pole, and the line is actually labeled with the RUS compatible standard for a piece of 1/0 phase wire and neutral. I take a look at the individual pole, and I not only can see the pole, but I can also see the conductors and the connectivity that's being maintained alongside of it. If you also notice that for the staker, I don't care whether it's color, line type, it's a dashed line or a color red, or attributes or everything else. I only want to show my staker what's really important to me in order to get to the job. So with AUD RUS, all the information is built into it. The layout becomes very, very simple and straightforward. With that, I can lay out any project, anything from the pre-configured 12 kV as well as 25 kV under tension or slack construction overhead and so forth as out of the box already go. So with that, Pete, I've done a little bit of layout. I've showed you a little bit of the menus, the palettes, the actual Project Explorer, so I can very quickly lay it out. And with that, I'm going to go ahead and toss it back to you to continue on with the thought process as we get into more and more of what we're talking about here. So, Pete, I'm going to make you the presenter and go ahead and let you wrap things up there on the first part.
Well, I tell you what, I've got to be honest with the audience. So I see that part of the presentation quite regularly, and it always makes you smile at the ease of use. Would you agree there, Walt? It's just so easy to use.
Definitely, and that's the intent, is it's about a production. It's a production tool where I have staking sheets and I want to get them done quick, accurately, and to the point, and very fast for the customer.
Well, I had a quick question, if I may, around those palettes. And I hope you don't mind me interjecting. We did tell the audience it's going to be slightly conversational. But the palettes, you said they were pre-configured, but can they be easily changed to match a utility standard, so utility-compatible units, for example?
Definitely, Pete. The average utility will incorporate the majority of what we show on the palette, and but it does allow the users to add on, subtract from. But what we do is establish a great starting point for the configuration of AUD to RUS standards.
Perfect. And of course, because it's easy to use, because it's based upon an AutoCAD-based solution, and look at some of the business challenges that a lot of utilities are dealing with today with knowledge base, potentially retiring from those utilities. You've got and I'm paraphrasing, and stop me if I'm wrong, but you've got a solution here in the way of the AUD RUS solution that and let's pick this carefully, a novice user, somebody like myself could pick this up quite quickly. Would that be a true statement?
That would be definitely a true statement because, again, built into it are all the standards for design, for drafting, and the layout. And we'll move on here now to the actual engineering part of the standards also.
Well, great. And that was a good segue, and that wasn't done on purpose, by the way. It sounded like it did, but it wasn't. But let's talk about the standards. So I'm going to throw it back to you.
Okay, great. Thanks, Pete. Again, the second piece of the pie, first was the layout, everything to standards, but then the second piece, it deals around the actual RUS construction standards. So everybody has design standards. They're specific to the RUS. And what are they? For instance, voltage drop and flicker calculations on the secondaries and the transformers, so that every single overhead transformer and every single secondary conductor and service conductor is sized appropriately to the load. All those standards are built into it. Sag and clearances. So when I drew that line, and I'll show it to you here in a minute, it can actually calculate the sag, the wind loading, ice loading, temperature, clearance checking, and so forth, and then size the poles for the appropriate wind and ice and temperature and so forth, and the equipment loaded onto it. And then finally, of course, we need to guide that. So a lot of these RUS standards are, in fact, built into the software so that, again, like you mentioned, a novice user can incorporate that without having to refer to their cheat sheets or charts or spreadsheets or subsequent, basically their standards books. It makes it all very easy. Sorry, I was jumping around here a little bit. Now, as far as the actual methodology we have, again, just like the layout, everything is built into it for those actual calculations. And not typical to a traditional utility where everything's done a little bit differently. Again, we build into the RUS standards into it so that out of the box, all those methodologies are incorporated. Go ahead there, Pete. Next slide. And with that, I'm going to jump right to a demonstration, and we'll go ahead and take control back again, and we'll jump back to the project that I was laying out just a few minutes ago. So we've completed the layout. The second piece of the pie then is to actually engineer it. This is where we really put the AUD software to its tests and take care of everything. First of all, we have an overhead line. That line was basically drawn on the ground. We need to bring it up into the air and sag it in based on the conditions on the sketch. I can either do that through ruling span for multiple spans, so I may have, unlike this case where I have just 2 spans, I may have 20, 30, 40 spans of wire over miles of length, typical rural extension. Or I can do it as an individual span with dead-end construction. So I'm going to do that here just in order to demonstrate the software. I'm going to go ahead and click on that piece of conductor. It's going to take a look at the adjacent piece of conductor, noting that it's tied in under tension to the individual pole, and go ahead and then solve it. Now, AUD then, with the RUS standards built in, takes a look at those conditions, brings the phase wire and the neutral up into the air, and sags them into the minimum clearances. I can take a look at each individual level, and by the way, I can maintain up to 16 levels on a pole, so I can do this all the way from the static wire of transmission all the way down through distribution and secondary and even foreign utilities. But not to elaborate too much in depth, I have the cross-arm assembly unit information that has now been suggested by AUD to RUS standards. I have mounting heights for those cross-arm assembly units, deviation angle to that one angle pole, and so forth. I have the conductor data under normal stringing conditions, extreme cold, which will include ice and wind, and extremely hot conditions, taking the maximum sag that's produced and maintaining that above ground, above traffic, or even a walkable surface, and then, of course, between each conductor that's on that pole line. So a lot happens, and maintaining clearances is part of it, and not only between the conductors, but over those individual items. So as you can see, with one click, I can move through many, many spans of wire. But what it happens to, as far as the staker is concerned, up at the top, it says that I've now recommended that the system is within RUS standards and that we're ready to go ahead and proceed with the next piece of engineering. That piece of engineering is to size those individual poles and to guide them accordingly. That's done, again, with one fell swoop, one click of the mouse. I can go ahead and touch the individual pole, and it'll take a look at the strains that I previously calculated when I sag the pole. It will come back and it will recommend a size of pole. If it's existing, it will tell me that this is the minimum, so that if that existing pole is undersized, this is now the size of pole that's required. It also tells me the types of anchors and size and lead distances that are required in order to maintain it to RUS standards. I can take a look at that. I can modify leads. For instance, I have a 25-foot lead, so I can change all the leads and say maybe I want to make it 15 feet because I have a right-of-way problem. And so I can go ahead and do that, automatically search for everything. I changed everything. I still have a 40-foot class 4 pole, but it allows me to go ahead and do what-if scenarios very easy, very quickly. And then when I'm done, go ahead and click it, and it will actually place the anchor assembly on the sketch. To do it quickly on this angle pole, you can see how fast a user would take a look at it, require it, and so forth. Whoops, I don't know what I did. I apologize. This is what happens with a live demonstration here. I forgot to sag in the overhead conductor going the adjacent direction. So I'm going to stop here very quickly, and I've got to take care of that. And it's stopping because...
While you're doing that, I'm glad your 40 years worth of experience is standing in good stead, by the way. Hey, while you're just cleaning stuff up, can I ask you a quick question?
Sure.
That conductor data, where you're identifying the loading on the conductor, the pounds per feet, can those engineering calculations be configured for my utility? Because based upon my geography, I'm maybe not worried about ice loading on a conductor.
Very definitely. The configuration for ice, for wind, will vary throughout the country, and it's all configured in tables so that the actual utility can make changes. You can even allow the individual staker to make changes. For instance, they're working in an area where there's only, for instance, a ½ inch of ice versus a ¼ inch of ice, and allow the user to make a quick change for an individual project. So with that, I apologize. I'm talking too fast here in a conversation, and I simply had forgotten, well, AUD and RUS is smart enough to know and will only guide what I actually sagged in. So now, as you saw, I went back in there and sagged in the adjacent conductor, and then it successfully guides in both directions as a line and buck position. So with that, I'm going to also take a look at load. I need to very quickly place a transformer on that pole. That transformer on that pole is to serve a customer. I'll just go ahead and place that symbology. I'm going to go ahead and place in a service into the pole, and now take into the results what that sizing of that transformer should be for that individual service. That's part of what we do in the second or voltage drop and flicker analysis. I can take a look at the individual pole, but first I need to go ahead and tell it what size and type of transformer I'm going to use and the voltage associated with it. For instance, I'm going to use an overhead. I'm going to use a single phase 12240 service voltage, but I also need to know what size and type. I may have two different possibilities under a 7.2 system, and I'm going to take the more complex dead-end configuration for the transformer, and I'm going to say fine. Then when I go ahead and check the voltage drop and flicker size the transformer, it goes ahead and, even though I touch the transformer, it traces out all of the secondary services, finds the default load for that service, and runs the calculations. You can see here then it's ordered out a specific transformer, in this case a 25 kVA for the 10 kW load that I had set up. It shows me the maximum voltage drop and flicker allowed in the transformer, and the secondaries, and the services. So as I took a look through here with that one click of the mouse, I've done a lot of information. I've sized, and in this case I could have multiple services. I could have multiple secondaries. Off that one transformer, but with one click of the mouse, I've established and set all the RUS standards to fit that situation. And when I say go ahead and do that, I've now set aside and done all of the engineering associated with this, guide it, sagged it, size the transformer, size the service. And with that, Pete, I'm going to throw it back to you as to move on to then the third piece of the pie to do with the ordering of material.
Well, thanks, Walt. Again, it never ceases to, I shouldn't say this, but it really never ceases to surprise me how easy it really is to use. And again, emphasizing the fact that we've already gone through the layout. We're dealing with our construction standards in that last example and changing those standards because, as you said, every single utility will have nuances, geographic nuances. By the way, question, talking about the geography, could I have loaded my map base, my cadastre for my GIS or mapping department as a backdrop?
Very definitely. The staking sheet can be laid out not just on your maps, your mapping system. You may have USGS topography maps. You may even have aerial photographs. All of those can be an underlying base map, so to speak, that you can lay out your staking sheet on.
So as a utility, I wouldn't, well, again, I'm not picking my words carefully. I'm giving the reality of the situation. As a utility, I can put together my projects very quickly, potentially from data that's already freely available for download somewhere out there on the web.
Absolutely.
Because I may not have the benefit of a mapping or one of those things called a GIS department within my utility. So, but I need to put together my designs very quickly.
Absolutely.
Perfect. So we've gone through the staking sheet layout as an engineer. We've started looking at our RUS construction standards. And again, very, very nice how they can be, the standards can be configured to conform to my specific needs for my utility. But at the end of the day, I do know that somebody somewhere along the line has got to prepare some materials, got to order materials in order to put this project together. So again, without further ado, Walt, can you take us through the material ordering section?
Absolutely, Pete. And it's all about ordering the material and actually producing the final finished staking sheet. And when we talk about that, we're talking about the RUS standards, our business rules built into the software. So that when I talk about business rules, I'm talking about the associations. You saw me with conductors and poles and transformers, but the association between those objects create the business rules by which those individual compatible units or stock numbers are actually ordered out. So built into the software is the basic generic components that order out those compatible units for the individual. Now, looking at the methodology again, as we've done in the past, the methodology says that an extreme amount of configuration is required for that business logic, the compatible units, and so forth. But when we have the RUS offering, it's all built into it. Now, the business units, the business logic that's built into it may not quite match what you and your individual utility requires, but it's to RUS standards. But what we have to do, and next click there, Pete, is we have to associate those compatible RUS standards to your individual utility stock numbers or compatible units, because everybody's different. Everybody has different. You may be building to an RUS standards, for instance, to an A5.1 or -1, but you have individual stock numbers that fit that. So that's where we associate the two. So when you take a look at the association, all the business rules, all the components are built to those assembly units to RUS standards, but then we simply associate the actual material, and this is on iChart, I know, from an A1.01 or an A1-1 to your individual associated number, stock number. So that way when the business logic is run, the actual component or stock number or compatible unit that is from your utility is actually ordered out on the bill of material. So with that, we're going to jump back into our example here and finish out by ordering the material and creating the final finished staking sheet. Now, I mentioned also earlier ease of use. Those business rules are built into it. So when I come over here to the right-hand side of the palette under Order Material, I simply go up to Automatic Material. It's automatic. The reason is because those associations that I drew around, for instance, this takeout pole, everything's associated with it. AUD takes a look at those and runs the business logic. So simply taking a look at it, it's asking me down at the bottom of the screen for the backspan for the staking sheet. There isn't one, so I'll simply press Enter, and it will go ahead and run that business logic and order out all the components ready to go. Now, I take a look at this, and I have it because I drew it. I've got a new pole here. It wants to order, but I know it's an existing pole. The other things I might want to tweak here is maybe that dead end. Maybe I want to go ahead, instead of installing it cold, maybe I want to do it hot. So there is the ability for the staker to make adjustments. Remember, the philosophy around AUD-RUS is that here are the RUS standards. This is the recommendation, but the staker's still in control, and we'll go ahead and make adjustments accordingly. Down at the bottom half of the screen, I have my entire inventory of compatible units. AUD-RUS sees that I'm working with anchors, guys, cross arms, and poles, so it will give me categories for that. It sees if I'm doing other things like transformers or cutouts, fuses, capacitors, it would also include those. So it's smart enough to know what areas I would want to add material from. But sooner or later, I'm finished. I like it. I'm working with this staking location, and I've identified that. Now, as to a user, I'm going to go pretty fast. I'm going to go down to the next pole. It's going to ask me for the backspan. I'll create the backspan, and it'll go ahead and order everything out. Now, in this case, I'm satisfied with everything. I like what I see. There's the backspan length. I'll just simply say, fine, okay, and I'm off and running. It's stake location number 2. Now, the final location is the pole with the transformer on it, and the backspan coming to it, and it goes ahead and locates it. The transformer assembly unit was not found, so any errors that it might find above will actually be shown so that it offers the user the opportunity. Maybe it wasn't available. Maybe I could come down and pick it out. It wasn't available in my inventory for whatever reason, so that it warns the user, the staker, to go ahead and add on any information that I want to in order to complete the project. Sooner or later, I'm finished. It orders out both the backspan and the service as location number 3. So I've ordered out the material. I can simply order out and export that material then to a staking sheet or a bill of material and so forth. And within AUD-RUS, I actually have job summary types of reports that are included so that I can actually take a look at that material. So the material is an example report. Your reports may be a little bit different, but it allows me to actually print out that material accordingly, and then, if required, electronically transfer it to your accounting system. So this is an example of what we use, and it's included. But sooner or later, I've got to get to the point where I'm actually working with that staking sheet. I've got a job here, so I want to go ahead. Maybe I want to work with it on an individual scale. So I want to go ahead and include it, an individual plot, and you can see I've included it. I actually create the staking sheet, and if you look closely, this is a generic staking sheet, but all of the information is coming from Project Explorer for name, address, job location, job name, and so forth, and then each individual stake location with the backspans, the size of conductors, pole heights, classes, and so forth, so it's automatically populating the staking sheet accordingly. So with that, I've actually completed my staking sheet. I've completed it, and I've drawn in a sketch to scale, and I have my material list. And with that, Pete, I've completed my stake with a lot of explanation of what I'm doing here. But at this point in time, I will end up throwing it back to you.
All right, well, why don't you throw it back to me? I'm going to ask you a couple of quick questions. And by the way, just a brief synopsis. I'm looking at what you produced there, and you produced your stock report, basically. You've given, as we got here, as it says on the screen, you ordered the material straight off, and it was just again, the ease of use based upon my utilities business rules association, the compatible units. And forgive me for asking, and I should know this, but I have to ask. Compatible units could be different between utility to utility. Is that correct?
Correct, absolutely, and they will be. Everybody has a difference. So the pull top assembly to RUS standards will be basically the same, but the actual stock numbers might be different.
Okay, and I love what you said about the staker has control. Not only does the staker has control, and you saw, again, the staking sheet, how quickly that was to produce, but just through the ease of use. Now, we can recircle, and we've got about 15 minutes left. We can recircle and talk about the benefits and the sort of words and the blah, blah, blah. I'm going to challenge you, Walt. I'm going to see how you feel about this. Do you mind if I ask a favor?
Sure.
You're wondering what this is, aren't you? I wondered if you would be kind enough to demonstrate exactly what you've shown, but as if you were an engineer putting together a staking sheet. So what I'm asking in, I don't know, 5 minutes or less, embellish here and there if you want to, but just go through from start to finish, produce a staking sheet, a layout, and do some material ordering and produce a staking sheet. Can you do that for me?
We'll sure give it a try here.
Okay.
Go ahead.
I know you're in sunny San Diego, and I know there's possible limitations for being in sunny San Diego. I'm joshing. It's lovely and sunny up here, by the way.
Okay, well, yeah, okay. Pete, great observation, because what about it's about productivity, and it's about producing a staking sheet. You'd be, in a normal course of the day, you'd be producing 4, 5, 6, 7, 8, 10 staking sheets for very simplified services. Okay. So, yes, I'll kind of jump over here to another staking sheet. Maybe I want to put in I had one that I just started earlier this morning where I want to put in a 3-phase pump to a well. And maybe I'll do that overhead real quick. So I'm going to go ahead and do that. I'm going to save the one I was working with because I'm going to come back to it later. But I'm going to do a little bit, maybe something a little bit different in the base map. You mentioned earlier maybe I have my AutoCAD drawings. This is a little bit of a variation on what we're doing. So I have drawings that I want to clip my existing facilities from. So I'm going to work with in a specific area that I want to work with here. And I'm going to clip it out, and I'm going to come into it. So now I have my existing takeoffs. I take a look at that, and okay, I've got conductors, I've got 3-phase, and I've got secondaries. Okay, that's good. Now I'm going to go into my overhead layout, and I've got over on this side of the road, I've got a 3-phase pump, so I need to place a pole, and I happen to know about the area where it's going to go. It's going to be here, and I've got a meter location for a little pump house right here, and a meter type, and so forth. And then I'm going to go ahead, and this time I've got 12 kV, and I've got 3-phase, so I'm going to put in some 3-phase 1-aught from my existing pole to my new pole. I'm going to, okay, that looks good. I'm going to engineer it. I'm going to sag it in by length so that as a user, I may be doing this very quick. It says that it's a tying in, okay, very good. And it's going to take a look at it. All my systems is now recommending tolerances within the RUS standards. I have a 280-foot span length and so forth. But I won't spend too much more time looking at it. I'll go into my engineering then and size my finished pole. So I'm going to calculate the guide and pole loading for my finished pole here. And, okay, it's a class 4, but maybe, okay, I don't want a class 4 because I'm going to put a 3-phase bank on it. So I'm going to change that pole out, okay. I'm going to put in a taller pole. I'm also going to adjust my leads because I want a 10-foot lead because I have a right-of-way problem there up against a building. And I'm going to accept that. So I've got my leads, my anchors. I'm going to go ahead then and install a transformer on it. The transformer is just a transformer because I haven't sized it accordingly. And then I'm going to put an overhead service into it out to this load. And I'm going to take a look at that load then. And I'm going to say that I'm going to design this then for 3-phase overhead, 12208. Transformer count is a grounded Y overhead. Okay, so I'll do that. And then, well, I've got a load here. Maybe I want to change that load to be a 25 horsepower pump. So I can give AUD-RUS different variations on load. So I'm going to take care of that. So I've identified this load as being a little bit different. And then I'm going to go ahead then and engineer and size the transformer. I'm going to adjust the wire. I'm going to allow it to whatever size transformer it wants to. And we'll go ahead and through it. It captures that. Let's see what we come up here. Now it says it's going to take 3 15 kVA in a grounded white configuration and so forth and so on. So it's within tolerance. It's sized the transformer, so I'm happy there. I've got a guide. I've got it engineered, so it's about time to order out the material. I'm going to automatically order out the material on the existing pole and identify one of the back spans and go ahead and allow it. Overhead engineering is not done on this one run. Yep, I didn't do that intentionally, but it's, again, a warning. So I'm going to like that. I'm going to do location number 1 for my first, and I'm going to then go into my second pole and the back span accordingly and allow it to size it. Again, it's telling me that it can't find the warning, but I'm not going to spend too much time on it. I'm going to say, fine, it's okay. Location stake, location number 2. I'm going to export the material. I'm going to see my new material list. There's my job summary. So I have all my material already loaded out. And then finally, I'm going to go over here again and produce my actual staking sheet. And I'll take a look at that. So my staking sheet is cut out just the portion of the drawing that I need. It's located and identified my actual 2 stake locations, my back spans, my conductors, my pole heights and transformer heights and so forth. So with that, I think, Pete, that kind of gives you a very quick synopsis without a lot of embellishment to handle it as if I were a staker trying to get a quick well in service. With that, I'll go ahead and throw it back to you.
So it's not inconceivable for a staker to maybe do 6 or 7 of these quite easily during the course of the day with the AUD-RUS solution, correct?
Absolutely. And maybe it's a 5-mile extension or a 1-pole extension. The idea is be quick, be efficient, be accurate.
And you've highlighted, in essence, the key benefits on this slide at the bottom. It was just increasing that, or improving, I hate using the word increasing, shouldn't have used it, but improving that staking sheet productivity and potentially quality as well. But optimizing on the material expenditure, just ensuring you know exactly what you have and what's going in there, and having a consistent solution that can be used. In this particular case, I feel confident that I, as a novice user, could pick this up very quickly indeed. Thank you, Walt.
I think it's a big point there that you mentioned. It's consistent also.
Yes, the consistency. Oh, by the way, one last quick question from me. I know the palettes were configurable, and I know that we can change the standards to accommodate my own utility. Symbology. Can I use my own symbology?
Absolutely. We've come up with a generic symbology based on RUS standards, but everybody does things a little bit different. They are AutoCAD blocks, so they're a little bit more intelligent. So we can even take the existing AutoCAD blocks used by a utility currently, make them a little bit of intelligence, add the intelligence for AUD-RUS, and then simply move on so that your finished staking sheet looks exactly the way your staking sheet looks today.
Perfect. Excellent. We did have some slight challenges with young Alison earlier. Alison, can you hear us? We can't hear Alison, so that's quite interesting. We do have, and I'm sure there are a plethora of questions online. Now, I do know that our partners, DLT, will be taking those questions. We couldn't get to them today, and we seem to have some technical issues talking to our friends at DLT, but not to worry. I've actually got one question, Walt, and it's a 2-part question, and I will ask you. We've got a few minutes, and I hope you don't mind me asking. But what is the AUD-RUS offering? And the second part of the question is, Is it available now? Can I get it today?
Great question, Pete, and it's probably one that's being asked. The AUD RUS solution is available now. It's been available for several months. And what is it? It is very specifically, as we've been talking along right now, it is a configuration of AUD with the RUS standards already built in. We took the, you might call it the 80-20 rule, so that for most utilities, their normal course of business laying out staking sheet overhead, it incorporates what would be required for 80% of the time to build any staking sheet overhead. So the idea is that out of the box, and the offering is exactly that. It's a box, and it comes with all the intellectual property and all of the configuration already built into it. And the idea is that we show up on Monday morning, and the configuration is tweaked and modified as we have available. And during the course of that week, the training is included. And then by Friday, a utilities engineer or staker is actually laying out staking sheets.
So in a week or less, basically?
Absolutely. The whole intention is that in 1 week's time, that the utility staker is up and running and in production, laying out staking sheets, just as you saw me do today.
Perfect. Well, I've actually got some quick questions from Alison. She's managed to get hold of me via some other form. Walt, I'm going to run through a couple of these questions. We can answer them quickly for the audience. That'd be great. Question, can we use Autodesk Revit to use this application? Do we have to use AutoCAD? The answer is this solution is based upon AutoCAD utility design, which is built upon AutoCAD map, which benefits from all of the AutoCAD functionality. So it's an AutoCAD-based solution. Correct, Walt?
Absolutely. And one thing it does bring up to highlight here that DLT reps will be talking with the utilities is this is a natural upgrade, cross-grade from AutoCAD or from AutoCAD map. AutoCAD is the basic engineering platform underneath that takes care of the CAD, map, the ability to talk geographically, AUD, the ability to create that staking sheet. So it is one product, but if you already have AutoCAD or AutoCAD map, there is a upgrade, cross-grade path that DLT can work with you on.
Perfect. Quick question specifically for you, Walt. I think, will AUD compute labor and material costs, the man-hour estimates?
Absolutely. Not only every single compatible unit or stock number will have associated material, labor, transportation, indirects, overheads, and then the whole project will also have indirects, overheads, engineering, interest, and so forth. And all of those are your individual utilities requirements, and AUD RUS will calculate that as part of that worksheet that I showed you. So we not only do a cost estimate, a job summary for parts, but a separate report as an example, and I did not have a chance to show it here. We'll actually do the cost estimate as well.
Perfect. Time for maybe one or two very last questions. Does AUD RUS now have a method to handle continuing plant records, CPR information?
I'd have to probably get into that question, kind of understand, and I apologize, I can't hear the
let's take that offline, and we'll get an answer for that particular listener. One that intrigues me, and I have no idea what it means, so I will ask you, Walt. I have no idea if I'm going to send you up the garden path. Can you design in other utility attachments, parasites?
Yes. All foreign utilities, there is a default foreign utility built into the software at a specific height, so it's maintaining clearance, and it has weight, cross-sectional area, and impact on the poles. You can also, and that's there without even drawing it. And I think I had my default set at 18 feet for attachment pole up, point on a pole and a load. And then you can also add additional telephone or TV or other forms of attachments to the pole and actually draw them on. For instance, if you have a very large telephone copper cable or something along those lines, and then it will engineer and take that into consideration also.
Perfect. So that was a yes, a resounding yes by the sounds of it.
Yes.
Fantastic. Like I said, we do have challenges with our friends at DLT, but I want to highlight both Sean Gaffrey and Dan Ward as your points of contact at DLT. The number is most certainly there on the screen, their email address. And if you do need to get hold of either Walter or myself, please contact either Sean or Dan, and they'll be able to facilitate dialogue with both of us. It is just over the top of the hour. I'm being very rude. I've taken 1 minute of your time, but I want to thank you a lot for your extremely valuable time, and thank our main speaker today, Walt Smith, for explaining AUD RUS solution very, very eloquently. Thanks, Walt, for doing that.
Our pleasure.
And